In this video, I'll go through some examples involving angles and triangles. So let's suppose we have this diagonal line here crossed by two parallel lines here. If this angle is, say, 70 degrees, then the opposite angle, which is this one over here, is also 70 degrees. And then the angle over here is called supplementary to the 70 degrees, and it has to add up to 180 degrees. Two supplementary angles add up to 180. So this would be 110 to make this 180. And then we can see that this 110 and this 70 are also supplementary. They add up to 180. And then this one over here is 110. And we can see that that is opposite to the 110 here. And then when we've got two parallel lines crossing another line, we have corresponding angles. So for example, this 70 and this angle here are corresponding angles, and because these lines that cross are parallel, they match. So this is 70 degrees. The corresponding angle to this one is 70. Corresponding angle to this 110 is 110, and then this one is 110 as well. Moving on to the triangles, let's suppose this angle was 30 degrees and this angle was 50 degrees. Then what would this angle up here be? Well, the sum of the angles in a triangle is 180 degrees. So this is 30, this is 50, 30 and 50 is 80, so this must be 100 degrees. If we have a triangle where, let's say, this one is 70 and this one is 40, so 70 and 40 comes to 110, and so 180 minus 110, so this one over here must be 70. So we've got two equal angles and one that's not equal, and that's called an isosceles triangle. And then let's suppose this angle was 60 and this angle was 60. So 60 plus 60 is 120. 180 minus 120, this one must be 60 as well. This is called an equilateral triangle. And in an isosceles triangle, these two angles are the same, and these two sides' lengths would be the same as well. And then in an equilateral triangle, all three side lengths would be the same, and the bottom one as well. Down here, I've got a special type of triangle called a right angle triangle, because these angles here are all 90 degrees, and this is denoted typically with the angle being squared off like this. That means it's 90 degrees. Normally when we mark off an angle inside a triangle, we would just mark it with a curved line like this, but with a right angle it's squared off. And we have something called the Pythagorean theorem that allows us to calculate one length of a triangle if we know the other two lengths and we have a right angle. So for example, if this was length 5 and this was length 12, then the length of this other unknown side, this is the hypotenuse, it's opposite the right angle. We calculate this by squaring one length, squaring the other length, adding those squares together, and then taking the square root. And if we do that, we get 25 under 144. That comes to 169, and 169 happens to be a perfect square. The square root of that is 13. We can also go the other way. So let's suppose we were given the hypotenuse and this side length. We could figure out the other side length, and for this we have to take the hypotenuse squared and subtract the other length squared, and then take the square root. So we would have 169 minus 25, that comes to 144. Square root of 144 is 12. And then one last example, if we had these two lengths, we could figure out this one. We would take the hypotenuse squared, subtract the other side squared, 12 squared, take the square root, and in this case we have 169 minus 144 comes to 25. Square root of 25 equals 5.